here for those of you who are keeping track. And what I'm going to go through here really quickly is this is just again a bit of a demo on how to use this thing as a whiteboard, Algodoo, but also go through some basic math which is coverable now according to the Common Core state standards at ninth grade or 8th grade, because you're supposed to deal with matrices at that level, and they talk about 3 by 3, but you can slide that up to 4 by 4 as long as you put it into context, and this program is going to show you why that might be a good idea. So what I've got going here, just so you can see, Algodoo is recording and I've got it stopped. The animation is stopped. I've gone and selected a new scene, and for now I'll just keep it in the basic default scenario, and we're going to talk about the basic accounting, if you would, or how matrix algebra, linear algebra, applies to something called graphs, but then also tie that into what a graph is in real math, or let's say something beyond ninth grade, so these students can start understanding that the term social graph is stored in matrices as well. So I'm going to go ahead and just kind of draw up a linked node network to start. I'm using the glob tool there. I'm going to go ahead and put one glob there. That's a glob. That's a node. And this is a node. And this is a node. And those are 3 nodes. And you're going to see later on when I click on them, you're going to see they actually are assigned names or numbers. So these nodes, and they can basically be shown to graphically, they're shown as having some volume, area, etc., and that's what this program does. I'm going to go ahead and turn this on. You'll see what happens. Oh, they're going to start to fall down to the ground. That's all well and good. And I'm going to go back here now. Now, if you just think about as these being node 0, node 1, and node 2, I'm going to now tie them together with springs, which would be the links. And I'm going to go ahead and link that one to that one, and this one to this one, and this one to this one. And once again, you get the concept now of nodes and links, or edges as the case would be, however what nomenclature you're using, and we're going to go through that in a little bit. As I turn that on, go backwards here, I'm now going to turn on, and it had a problem with that. Oh, there it is. There they are. Hit here and go backwards. And I'm just now going to kind of process this and see if anything happens. It does not like that. So I'm going to go undo, undo, and undo. And we'll try it with a chain instead. And so I'll show you the way to go about connecting with the sketch tool is if I go from here, starting on one, ending on another, it puts a chain. Same thing here. I didn't like that. I'm going to once again go from there to there. It does it again, and I'm going to go, if you notice, I'm keeping track of the direction I draw. And so if we have this as being node 0, node 1, and node 2, this would be edge that goes from 0 to 1, this would be the edge that goes from 1 to 2, and this would be the edge that goes from 2 to 3. If we assume that there's some sort of direction in that. I'm now going to turn this on, and you notice they're falling together, and then when they get to the ground, because those chains are obviously just chains. So we have, finally, I'm going to add one more node, and if I'm going to go ahead and use a little bit of not necessarily text, but so you can see it, I'm going to go ahead and call this node 0, node 1, and node 2. I'm going to call this, for now, so we can start keeping track of them, edge A, edge B, and edge or link are the same thing within the discussion of graphs. And in the end later on, so I'm going to add one more node, and that node is 0, 1, 2. This node would be, make it a little bit bigger here, trying to fill it all in. We'll call that good for now. And that will be node 0, 1, 2. This would be node 3. Right? And we can add a couple more links. We'll see how this works. Now we're going to go, and what we want to do is we want to think about the direction that we're drawing these things. And in the end, I was drawing incorrectly if I did A, B, and C, because when I went this way, I went actually clockwise, and positive would be potentially counterclockwise, but I'm going to keep the same way. So I'm going to kind of go draw this one from there to there. Didn't like that, I'll try it again, because there's nothing there for it to grab onto. I'm going to go undo, redraw the node if I would. I'm just going to draw the node that probably I should have in the first place. Draw the node right like that. And this time I'll once again draw my link from there, there, and from there to there. That didn't work. Again, this is recording. It's up to 31 megabytes as we speak. I didn't like that. I'll try one more time. We'll go with an undo here. Alright, so hopefully that connected. So we have node 0, 1, 2, 3. We have edge A, B, C, and I'm going to add, of course, now edge D. Undo. Using the kind of crayon brush tool, A by C, D. So the E and edge E. Okay, tough writing on this. Alright, so we now have nodes defined, edges which have some direction which we're not showing, and then in the end you're going to have faces. And the faces are going to be defined by being enclosed by edges. So those are the three constructs, and they're either known as nodes, edges, and faces, or vertices, links, and faces. And with that, you can get into a lot of topology, and more importantly, perhaps within matrices, a lot of relatively straightforward, standard ways to start using matrices for something beyond simple linear equations. So I'm going to turn this on, and it all falls to the ground together. And once again, we're now just looking at this kind of concept of, go ahead and pick this up if I could. This is something of there's something about the way these things are attached, which they just broke. So that you'll later be able to see is reasonable to talk about when you're talking about the social networks or paths to school or anything, any of the cool math that comes from the ability to do something a little bit more substantial than just solve simultaneous equations. So I'm going to go stop, backwards, 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 and I'm going to go ahead and save this just in case I have a use for it. Save a scene. I'll call this graph demo 1. Notice the underlines, no spaces in file names. I'm going to save. I'm not sharing at the moment. And now I'm going to stop the video, and when we come back, we'll look at the mathematics, or the way we account for, which would be our nodes, lengths, and then eventually also the faces.